It was a day like any other, when suddenly, BAM! New Discord notification. It's my friend Barrio. He said he wants to make a Roblox game complete with war, espionage, and countries for a new video idea, and needed my help to do it. But there's a problem. I would have to get everything done within 2 weeks before I had to leave the state, and wouldn't be back for the rest of the month. Now, I had some experience developing games in Roblox before. It's just that those games are never good. But I was pretty confident I could make a stronger game than Resonations. First, I just had to load up Roblox Studio and begin importing, but it was during this experience that I had to make a daunting choice, okay? I had to choose between developing on a flat versus a globe map. So if you've been on the Roblox strategy game community for long enough, and if you have, you need to reconsider your life choices. You'll know that most of these games are strictly on a flat map. Resonations is on a round globe. Now, the reason why most games do this is because it's just simply easier. Like, there's no reason to burden yourself with complex trigonometry just to make troops move across the globe, and then import this logic into every script you do therefore. It's like choosing to do math in summer, okay? No one does this. Now, Ron does this because the developer is simply insane, but competing against a well-established game is already what this video is about, so round globe it is. Now, I had some experience developing on a round globe before. If you've been active in the community, you'll remember Resonations 2 and how remarkably terrible that game was for modeling countries. So what they did was they took a literal Roblox part and then tried to shape it to fit the country they were playing as, which always resulted in some terrible amalgamation with no tile variety. Now, the way games like Resonations do this is that instead of using regular Roblox parts to make country tiles, they use meshes instead. So meshes are essentially an amalgamation of vertices, edges, and faces that make a 3D object, and you can be insanely precise with them. Now, the question arose as to how I'd even get this in the first place, since they wouldn't be available in the Roblox toolbox. So first I'll have to download a shapefile from somewhere to get tile data. Now, tiles are essentially a snippet of a country, and this would allow for players to be able to capture parts of a country without capturing the whole thing instead. Now, fortunately, the nations of the world have all unified together in a kumbaya circle out of pure generosity and friendship to have already created the tiles for me. You know how the US has different states in them? You know, all the other countries have things called provinces, which are basically the same thing. So this meant I didn't have to manually cut up the country at all. I just had to download the shapefile. All I had to do was find a site to download this data and then import it into Blender as a shapefile. Easy, right? Absolutely not. Now, what was easy is getting this data, but what was hard was to turn it into a sphere in Blender. I had originally tried to use the geometry node editor feature, tell me shift it into a sphere using geometry, but that was just way too lazy for that. So I just wanted to program it directly in the scripting console using Python. And after many tries, this seemed to work. So our next step was to obtain a file containing city data to correctly plot onto the map in Roblox. So conveniently, the data for every inhabited settlement on the planet can be downloaded for free in JSON format. So I basically win, okay? The way to plot these cities was actually kind of easy. I first had to download Apache server software and slap my JSON into it because the city data was just really big, and it was simply too much for Roblox servers to handle. After parsing all of it, all I had to do was run a calculation to see where exactly they would be positioned based off the latitude and longitude coordinates. Since the coordinate entries are in decimal degrees, we would have to convert it into radians, set it as a variable, and then apply calculations for each 3D direction. So quick math rundown for you. Latitude is the angle from the equatorial plane, and longitude is the angle around the vertical axis. So to get an X, Y, and Z coordinate, we just need to run these complex calculations and then multiply it by our radius. Post-editing here, I was going to add a really long segment about how the math would work out, but I sounded really nerdy, so I'm not going to do it. Now, that was a lot of math, but it was pretty important for discovering what happened next. So upon loading all the cities, I instantly realized the problem. The problem was that the tiles did not line up with the cities to a significant degree. So I did some research, and I realized that my country tile importing was all flawed because I knew the city selection was correct, but the Python script ended up projecting my flat map onto a sphere with disastrous proportions. In trying to figure out the error in my ways, I instantly remembered something important. It all goes back to 1827 AD. In 1827 AD, Carl Friedrich Gauss published a theorem which proved that you could not make a perfectly accurate map of a sphere, precisely because the Gaussian curvature of a surface is an intrinsic property, which remains unchanged under local isometries. So what this means is that if you have a curved surface like a sphere, its curvature is built into the very fabric of the surface. You can't simply flatten it without changing the fundamental geometric isometries, or relationships between points. Gaussian curvature measures how much a surface curves away from being flat at any given point. For a sphere, this is positive and constant, but for a flat plane, this is simply zero. Thus, Gauss's theories inherently prove that flat maps cannot be perfectly made without some distortion. This proved fatal for my script, as when I call the flat spherical function, I merely assume that every point on the flat mesh can be directly mapped onto the sphere, without considering the flat map had no Gaussian curvature. After this, I became depressed. I considered abandoning the project entirely, which would have devastated the 8 people that still watch my videos. I instantly hit rock bottom. By rock bottom, the only direction to go was up. In a flash of inspiration, I instantly remembered this quote from Charles de Gaulle. India is a big country, inhabited by many Indians. I decided to look up any YouTube tutorials to see if they could help me. And lo and behold, I found one that was somehow perfectly suited to my problem. This somehow converted a flat map to a spherical one with no issues at all. Now, I have no proof this guy's Indian, but, I mean, look at what he posts, okay? There's no other more likely to run this type of channel. So I got to work copying one-to-one the geometry nodes that they use, exported back to Roblox, and I finally had a working tile mesh within my game. I formally apologize for all the curry jokes. I didn't mean it. After this, I was finally able to get working. So fortunately, the shapefile that I use had metadata that would help me figure out which country owned which tile. So I got to work making a script that automatically assigned country values and colors, and this is what it resulted in the end. And yes, I know Germany's orange, okay? Don't yell at me. In order to get rid of unused islands, I made it so that if a province had no cities on it, the province would be deleted, which was a huge mistake because in some countries like Latvia and Slovenia, like half the provinces just got wiped, okay? There was also a bug with Kosovo where it wouldn't give me the owner value of the tile yet since Kosovo isn't an established UN entity yet. So, who owns Kosovo? No one owns Kosovo, in fact. Borders are just an illusion, okay? It's a figment of the mind. So the next step consisted of the player being able to choose countries. Now, this is very easy to do. All I had to do was code a GUI that listed every country, assign a color on the client side, and then update the player attribute. So attributes are essentially custom values for certain objects, which include things like numbers and strings and booleans and whatnot. So before this, you used to put an int value or whatever value into the folder, but this just became redundant. Basically, the way the script works is that if you click on a corresponding country button, it checks whether or not the country is claimed, and if the player already owns the country. If these values are false, it assigns the ownership, sets the color, and calls it a day. The script is a type of script in Roblox called a local script, which only runs on the client side. So the reason I don't set the player attribute here is because it wouldn't port server side. Fortunately, Roblox has a thing called remote events, which when called allows you to transmit data to a server side script, and then we were able to set an attribute there. Before we could start working on troop mechanics, we first had to work on a script that would let us select the cities to spawn troops in the first place. So if you ever played Rise Nations before, you know that you can drag select multiple cities to spawn troops in. Usually China players do this to take over smaller nations that are next to them. I had envisioned this to be particularly difficult because it involved importing a 2D view of the camera to 3D space, which is like rocket science. It ended up being more simple than I expected. The most important of these being the isPartInSelection function. First, I had to check the initial validation and then get the selection box screen coordinates and dimension in pixels when the player starts dragging. I also had to make a GUI that scales when the player holds down left click. Fortunately, Roblox has made it very easy to do this by literally using a function in the camera called World to Viewport Point, so I didn't have to actually make my own engine to do this. Godspeed to this unforeseen hero. And after that, I had to write an occlusion detector to see if the selection interfered with the Earth through raycasting, but that was really about it. Now later on with this script, we were able to move infantry using the drag select feature, which was actually a huge help for me. On the topic of moving infantry, this was a pain to do. So you know how in like games like Hoi 4 you could just make the troop teleport between provinces? You can't do that here, okay? In Rise Nations, you can just literally select the troop and click on somewhere to move it. There's so much variety with it. Now I had no problems creating a mechanic with this degree of freedom. The problem was moving it across the sphere. Now fortunately, people much smarter than I am have come up with the Great Circle. Great Circles are defined as being the largest possible circle you can draw on a sphere, whose center coincides with the sphere's center. They have an important property, which is that if you have 2 points on the Great Circle, that is the shortest mathematical distance between the two. Oh, but Gavin does wrong. Why does this infantry have to abide by the Great Circle? Well, I'm glad you asked that. Let's say you want to make a trip between South Africa and Russia. Let's also assume you can just pass through walls and no clip. The absolute shortest distance between the two would be taking a straight shot through the Earth's mantle and crust to get there. But we are bound by the laws of physics, unfortunately, and if you tried this, you'll kind of die. So, you can't simply cheat by tunneling or flying above Earth. You have to hug the curvature of the Earth, and this applies for my infantry as well. Anyway, back to this function. So this function is all about converting Cartesian 3D coordinates to spherical coordinates, which I mentioned earlier in the math tirade, but this is different because it's reversed, and we return 2 values. First, we had to apply distance theorem in 3D space, and then get the 2 variables theta and phi. In physics, theta measures the positive y-axis, and you can calculate its cosine by dividing y by the radius. Getting the arc cosine gives us the angle in radians. Essentially what this gives us is a range between 0 and pi. 0 means that the point lies on the North Pole, and pi means that the point is on the South Pole. Through this we get our latitude. Then we had to calculate the azimuthal angle of phi, which is just way too complicated, so I'm just going to skip it. Now back to this function. So first we have to get the theta and phi from our infantry position, and we get the end position from simply clicking on the globe while having infantry selected. So once we get the 4 variables we need, we can get the delta phi between the two. This measures the difference in azimuthal angle between the 2 points. Then we use the spherical law of cosines to get the central angle of the radians, and the more important math things you guys don't need to worry about, yada yada. We get the infantry moving across the globe, okay? Just a few simple tweaks, and we can finally spawn infantry on cities with certain attributes like the troop count and training experience, in addition to making things like forming lines and waypoints. There's so much infantry, you can just spam it out and then merge it, and then put it all into one stack. Now watch what happens after this. This is gonna get insane. Form lines, and watch what happens. The greatest thing ever is about to happen. Look at it. It's so good. It's so good. Look. Now the wrong draft players have to play my game. On an unrelated note, if you remember Resonations 2, you'd also know how if you tried to manipulate your camera, you would perceive it as being very clunky and weird. I had to code a zoom script that would allow for a much smoother movement, so it wasn't a complete eyesore. So fortunately by this time I had a week left till I had to leave to Iowa, so I had to get everything done within this week. The next system to get done was the economy system. Now this was actually really easy. I first had to set up a date system, then set cycles per 5 days to update the economy per person. Tax income and manpower increase is based on the population, so by running a scaler and updating this poorly made GUI at man of 5 minutes, we can actually see most of our economy stats. After that, the next thing to get done was the declaring war system and the diplomacy system, which was by far the hardest to make in this entire video. Let's say Germany, for example, and have serious ambitions for conquering Europe, but first you must navigate the diplomacy system. Basically, the system works in 4 types of ways. We have the neutral state, the allied state, the war state, and justifying war state. You can easily view your relationship in the GUI to justify war, and also, once war is declared on a country like Poland, you can send your troops to siege the other country's cities. If they're close enough, it begins a siege. If you succeed in sieging, you're literally able to plunder the city for tax income and manpower gain. Similar to Resonations, the amount of troops you have directly affects how long your siege is, and upon combat, the siege instantly stops. Combat is also similar between Resonations, where 2 units just kind of duck it out till the end, but the way the war system works is very elaborate, which it took me most of the time to make. Once combat is initialized, nearby units from allied countries are grouped into size, and the system checks diplomatic relations using global variables mentioned previously. Every half second a combat cycle happens, so for each cycle, it calculates total attack, defense, and troop count for each side, and attack and defense bonuses can be applied if the unit is trained enough or has enough technology, which we'll get into very much later. I also made some visual effects so it looks cooler to invade Poland now, I guess. So once Poland is completely gone, or if it returns to a standstill, you can initiate a peace through the remote event. There are multiple types of peace options. We have white peace, where all captured cities are restored between 2 countries, conditional surrender, where one country demands claims or reparations from another side, and surrender, where one country just gives up everything they have. Poland can offer an action back where they can offer a white peace, demand terms, a surrender, or surrender themselves. Then the script checks to see if the 2 countries are at war, and checks that no other active negotiations are on the table, then stores the negotiation with a unique ID. When you send a peace offer to Poland, Poland can directly see the type of peace it has and what territories and money to give up, and then decide to accept, reject, or counter the proposal. Once the peace treaty is accepted, a function is called to restore peace again. Also, in a little bit of a bug, in a test playthrough as Russia where I stormed Europe, I have a bit of a bug with the coloring, so every time I just conquered a country, it just looked like this. Also, this is very personal. For like about a week straight, I kept getting disconnected from Roblox Studio because of my bad internet, and just PMO'd me so much. I thought it was my just bad Wi-Fi antennae, but that was just wrong. So I ended up buying a 50-foot Ethernet cable from a Best Buy 40 miles away. I just picked up this 50-foot Ethernet cord from the Best Buy. I spent 40 miles getting to the Best Buy, and they finally had the cable that I wanted, just to make sure this would never happen again. I then proceeded to drive back in the worst conditions possible, but anyway, back to the video. Anyway, the next part of the game was to make the technology system, which was actually very simple, but it was just a lot of busy work to do. Basically, you could open the technology GUI, and if you have a good enough research points, you can research a specified tree within a couple of cycles and then get an extra buff to whatever you're researching on. It's very simple, but much of my writing was busy work and checks to make sure the play could actually run the thing they were trying to run. And at this point, I had about 2 days before I had to leave the state. I had to get espionage done and very fast, so I began just booking it. At this point, my summer volunteering was kind of done, so I could spend the next couple of days or so grinding to get this game done on time. After some time, it finally worked in all of its glory. So basically, the way the espionage works is that if you have to build a connection within a country and expending copious amounts of money to receive information from your adversary, first you gotta do Ctrl-M to get a list of maps and then click on the country you want to set up a network in. Once that's finished, you gain a list of operations you can do, like harm the country. You could do direct sabotage and military sabotage with a certain success rate. In return, there's counter-espionage, where you can directly harm the efficiency and maybe tear down a spy network. Have a country attempting to spy on you, leading to an espionage war trying to gain intelligence on your adversary and dethrone your enemy at the same time. You can also upgrade your network for a higher life of operation succeeding. And at this point, the game was done in all of its glory, alright? If you want to play the game, the link to it will be in the description below. Huge thanks to Barry for making many of the GUIs and helping with the project too, so go subscribe to him once this is done. And with that, the game is done. All the loose ends finally tied together.